Hi, and welcome back. This is textbook MIS6, and this is Chapter 3, Part 2 of video. So we're going to talk a little bit about the data administration portion of databases. And in most cases, you do tasks like backup recovery, change management, some security in some cases. It's used to determine who has permission to perform certain functions. And a lot of times you'll hear people refer to that as CRUD. And what that means is create, read, update, and delete. And so when you hear that acronym, that's what they're talking about. And that's what you do in a lot of cases when it comes to database administration. So a database administrator is often called a DBA. They do things like handle the design and management of a database. Sometimes the database is set up and they come in, or they do set up the database, so it depends upon the organization. They establish the user rights. Sometimes that's also provided by the security team, who may have some predetermined I guess measures that you need to take in the creation of rights for all users. So it depends upon, again, the organization that you're in. Recovery procedure, especially if data is corrupted. Do you have some redundancy? Do you have your data in more than one place? Evaluating performance, and fine-tuning the functions. So there are some recent trends in the design and use of databases. There's data-driven websites, and that's an interface to a database. And what it does is it retrieves data and allows users to enter data. Again, this would be something that would be very user-friendly, or it would have a GUI or graphical user interface that would make it really easy for users to be able to get information from the data. There's also distributed databases, which stores data on multiple servers. Most of the databases that I have been used or have been a part of are distributed databases. So what they do is they approach their data in a way where they have fragmentation, which are addresses on how tables are divided into multiple locations. They have replication or redundancy, more than one area that has a copy of the data. And allocation, which combines the fragmentation for replication. So they may have bits and pieces stored in different databases that are fragmented, but when they come together, they make a whole. There's also object-oriented databases. It's a single object contains data and their relationships. So that single piece of data, or that single object, contains both the data and the relationship. It consists of attributes and methods that can be formed on an object's data. There's what is called encapsulation. So what happens is there's a grouping of objects with their attributes and methods, and they're put into a single unit. And there's also inheritance. So any of the new objects that are created can be done a lot quicker because there's inheritance that go with the attributes that are the new data that's created. So data warehouses are a collection of data from a variety of sources. They support decision making for applications and business intelligence, and they contain, or they store, multidimensional data, and that's called hypercubes. So some of the characteristics of the data in a data warehouse is that they're subject-oriented, they come from a variety of sources, they are categorized based on time, It captures aggregated data, and it's used for analytical purposes. So here's a quick screenshot of a Visio diagram that really kind of gives you an idea of what a warehouse configuration would look like. And when you look at this, sometimes these diagrams can be confusing, but once you start to use databases, it becomes more understandable and it makes sense to you. And also, there are other ways to display what a warehouse looks like. This just happens to be the visual way of that they're showing you how the data warehouse looks. So input. So input is different sources of data together. So they come into the warehouse and the warehouse can perform analysis and generate reports. Some of the input could be from external data sources, from other databases, from transaction files. They can be from enterprise resource planning or ERP systems. They can be from customer relationship management systems, which are also called CRM systems. There's also the extraction, transformation, and loading, sometimes referred as ETL. That's a process that's used in the data warehouse. And what it does is when you're extracting data from outside sources, you can transform the data to fit your operational needs. It's loading data into the database or data warehouse and then extracting it for outside information. Storage is collected information organized in a data warehouse. It could be raw data, it could be summary data, and it can be metadata. So raw data is information in its original form. Summary data is subtotals of various categories, and metadata is information about the data's content, condition, etc., characteristics of the data. So output. Output can be in the form of online transaction processing, so it can manage transaction-oriented applications. It uses internal data and responds to it in real time. There's also what's called online analytical processing. And what that does is it generates business intelligence and uses multiple sources of information to provide analysis in a multidimensional form. Here's a look at slicing and dicing data. So it's a lot like, if in the way that I think about it, is like an Excel table. There are multiple relationships that are a part of each of the pieces of data. So the output, one of the big things that is part of a database and something that DBMs do is they do data mining analysis. So they discover patterns in relationship. Warehouses help generate the various types of information, like cross-referencing segments of an organization's operation and comparing them, generating complex queries and reports that you can use faster and more easily. Reports are become more efficient when you're using data from a variety of sources. So data mining analysis and how you use it can become very efficient in providing information to an organization. The outputs, what you want to do is find patterns and trends. If you analyze a large amount of historical data, you can do it quickly. It assists in management in making well-informed business decisions. It manages high demand information for many different kinds of users and many different kinds of needs. There's also what's called a data mart. It's a smaller version of a data warehouse and it's used by a department or it can be used as a function. The advantages of having a data mart over a data warehouse is that you can access the data faster because you're doing it in a smaller size. Your response time can be improved, and it's easier to create because it's usually smaller and more simple. It's less expensive, and it's a targeted kind of data mining, but it does have a limited scope. So business analytics, what that does, or what business analytics is it uses data and statistical methods to gain insight into data. Then it helps decision makers make decisions based on the information that they get. There are different types of business analytic methods. There's descriptive analytics, which reviews past events, analyzes the data, and provides reporting on what's happened. And then you have a reactive strategy. What's really becoming popular is the use of predictive analytics, which will prepare decision makers for future events, and it becomes a proactive strategy. But you can use the descriptive analytics to generate predictive analytics for the future. Big data era. So big data is a voluminous data which the conventional computing methods are unable to efficiently process and manage. It involves dimension known as 3 V's, which is volume, variety, and velocity. The benefits of big data is that industries can gain a competitive edge. Industries like retail, financial services, public relations and advertising, government, manufacturing, telecommunications, energy, healthcare. The factors that are part of the growth of big data is the wireless and mobile technologies, social networking, and enhanced power and sophistication of the smartphones and handheld devices. So, some key terms that you want to take away from this particular chapter is allocation, big data, business analytics, create, read, update, and delete, or another term acronym for it is CRUD, data dictionary, data hierarchy, data mart, data model, data warehouse, and database. Database administrator, which is a DBA, a database management system, which is DBMS, data-driven websites, data mining analysis, a distributed data management system, which is DDBMS, encapsulation, extraction, transformation, and loading, or another word for it is ETL, a foreign key, and fragmentation. Hierarchical models, index sequential access method, which is ISAM, inheritance, logical view, network model, normalization, object-oriented databases, online analytical processing, online transaction processing, physical view. There's also primary key, query by example or QBE, random access file structure, relational model, replication, sequential access file structure, and structured SQL or structured query language, which is referred to as SQL. So, in summary, in a database system, all files are integrated. Retrieving data from a database is much faster when you're using a database system. Files are accessed by special sequential, random, or index sequential methods. The components of a DBMS is a database engine, data definition, data manipulation, application generation, and data administration. So there are recent trends in database design that include data-driven websites, natural language processing, distributed and object-oriented database. There are data marts, which are focused on business functions or specific user groups in an organization. and industries benefit from big data analytics along with a competitive advantage. Thank you, and I'll see you in the next module.